So the purpose of this video is to show you how to take a proper measurement, both identifying the graduate, figuring out what the estimate value is, reading the measurement on the tool, and then attaching the uncertainty value to it and including the unit. So let's look at a couple of examples. I like to start with the beaker here. And if we look here, you notice the graduate here is going by tens. Okay, so the value of the graduate is going by the tens. So when we look at the water line, notice the water line, we look at the bottom of what we call the meniscus. So this is where we would read the measurement. When you're taking a measurement of a liquid, you got to make sure you're level with the table. So that's the bottom of the meniscus there. So we know for certain here, based on the graduates of the tool here, that this is between 20 and 30. That's what we can reliably say based on the graduates of this tool. Once you identify the value of the graduate, so we know the graduate here is going by the tens. This tells us that our estimate will be equal to 1/10 of 10, which would be 1. So when we take an estimate, it has to be in an increment of 1. It has to be in an increment of 1/10 of the graduate value. So how do we do this? Well, when we look at the image here, we want to visualize ten individual marks between the two graduate values. And each one of these marks is going to represent about 1. And we say, what we do is what we're looking for here is we're looking to see where the measurement line, where it lies within these estimate marks. And I would probably say it lies at the 3rd or 4th line here. Okay, so we have 10 equal increments between the two graduates, and I like to think it's falling between probably the 3rd or the 4th. 3rd or the 4th. Now, someone else might say the 4th or the 5th. The point is, it's an estimate. We don't know for sure. We're doing our best. Okay, and it's in an increment of 1/10 of the graduates. So if the graduates are going by tens, our estimate is going by ones. And we do our best to find which of those ones, in this case, it's closest to. So I might say, based on my estimation here, I'm going to say it's closest to the 3rd mark. So now we're starting to formulate a full measurement here. So we know it's between 20 and 30. So we're going to write 2. Okay, we know it's between 20 and 30, so 20 what? Well, I just said 23. Okay. Someone else might have said 24. Someone else might have said 25. Okay. We made an estimate there. We don't know. We know it's between 20 and 30. That's all we know for sure. So to admit that we made an estimate, we attach the uncertainty value. So we say plus or minus, and one increment, it's the increment of the estimate, which is 1/10 of the graduate, in other words, 1. So we say plus or minus 1, okay? And then we attach the unit. So this ends up being 23 plus or minus 1 milliliters. What about the thermometer here? What's the value of the graduate? Now be careful here. We have 40 here and 50 listed, but the value of the graduate is the value of the marks on the tool. So even though it's not written, I know that this mark here is 41. This mark here is 42, 43, 44, 45, 46, 47, 48, 49, 50. In other words, the graduate has a value to the ones place. So we ask ourselves, what two graduates does it fall between? Well, it seems to fall between 47 and 48. So with all reliability, we can say that this is going to fall between 47 and 48 degrees. It's going to be 47 something. Now we got to really zoom in. And when you're taking a measure, you might have to really lean in when you're looking at this. Now we make our estimate. And by the way, what's going to be the increment of the estimates? So if we were going by ones here, okay, 40, 41, 42, 43, 44, 45, 46, 47. If we were going by ones, that means the estimate so the graduate's going by ones, our estimate has to be an increment of 1/10 of 1. In other words, 0.1. So you need to make an estimate in an increment of 0.1. Okay, so we visualize 10 marks in here. 2, 3, 4, 5, 6, 7, 8, 9, 10. You make your estimate. Which one is it closest to? It's harder and harder to do, right? As the graduate gets smaller. I might say like the, I don't know, third increment. So I might say 47.3. Okay, which is valid because it's an increment of 0.1. You couldn't say 47.35. You can't say that with any reliability. It's got to be an increment of 0.1. It's got to be an increment of the estimate. And what is the estimate equivalent to? Again, it's equivalent to 1/10 of the graduates. So the graduates are going by ones, the estimate's going by 0.1. We made an estimate, right? So we admit that, we attach the uncertainty. So we go plus or minus 0.1, and then the unit of the device. And this is a thermometer, so we're gonna go degrees Celsius. Let's do another one. This looks like it's some sort of graduated cylinder, okay? Value of the graduate. So we got 8 here. This must be 8, 8.1, 8.2, 8.3, 8.4, 8.5, 6, 7, 8, 9. So it looks like the graduate is going by tenths. Therefore, the estimate has to go by 1/10 of 1/10 is 1/100th. So what two lines does it fall between? 8.1, 8.2, 8.3, 8.4. It's between 8.4 and 8.5. It's going to be 8.4 something. Okay, now we make our estimate. It has to be an increment of the hundredths. We're looking at the bottom of the meniscus. Right there, bottom of the meniscus. And when you really zoom in on an image, you can tell why you need to have a plan in terms of what you're looking at with a liquid. Are you looking at the bottom of the curve or the top of the curve or the middle? We always look at the bottom, okay? And that can be the difference between, a couple hundredths, which doesn't seem like a big deal, but it can be in an analytical science of the chemistry. So I'm going to say it's just above the line. Now, if it was right on, let's say it was right on the line, right on the graduate, we're still making an estimate. It would go not 8.4, it would say 8.40. Okay, so even if it's right on a graduate, if your estimate is in increments of the hundredths, you need to include that. It would be 8.40. 8.40 is different than 8.4. 8.40 is telling the reader that that tool had a graduate that was by the tenths and made an estimate to the hundredths. It's very important. I'm going to say it's just above though. I'm going to say 8.41 plus or minus the value of the estimate plus or minus 0.01 milliliters. Okay. By default, most liquid measurements in chemistry tend to be milliliters. Okay. So there you have it. That gives you kind of a general idea of how this approach is made when making a proper measurement in chemistry. And what's fun is every tool is a little bit different. Every tool has a different graduate value, therefore has a different estimate. When you talk about precision with tools, precision comes down to which one has the smallest graduate value, and therefore which one will have the smallest estimate value, okay? Tool number 2 here, because it goes out to the hundredths place, allows for a lot more precision than the tool that only allows you to make an estimate to the ones place. Does that make tool number 3 bad? No, it doesn't make it bad. It's just that it's not as precise, we say, as tool number 2. And it all really depends on the demand of precision for your particular experiment that you're conducting. So hopefully that helps you understand how to take a measurement. We're going to have a lot of practice with this.